Induction worksheet. Oh, I haven't turned my proof in yet.
Yeah, you should do that. Good afternoon, everybody. Welcome back to Discrete Math. Plan for today, you all are going to have the opportunity to do some group work on induction. Usual office hours on Monday, 11 and after class. And as far as homework for Monday goes, got another mistakes journal due Monday. And let's go see how class goes today. If you all work your way through the induction worksheet quickly, maybe we can start doing a presentation or two from that today at the end of class, or depending on how things go, we may just do all of those on Monday. Also, there is your proof portfolio entry for this week, if you want to turn one in, is due today. So see that I have that by the end of class.
I think somebody already asked this, but for the power set one, that's like not one of the.
Yeah, that one had a big typo in it.
Oh yeah, I mean I got the typo. I meant like, does it fit under which of the 12 types of proofs?
I think that would be a good set theory.
Okay.
Proofs, I don't know, non-indexing set proofs. I should start labeling these. I didn't do it for the first three because a lot of the first three were like, oh, you could do this directly or by contrapositive or by contradiction, and it's up to you. But pretty much the rest are all kind of do one from this topic. I should start labeling those. I'll do that from now on. Because sometimes you get something and maybe a little bit unclear.
Well, I just mean for keeping track of like when we turn it in at the end, like if we did this power set one, like that's our one for like the set theory one.
Quite. So, one day, a psychologist is running an experiment. Gets an engineer, a physicist, and a mathematician, locks them all in a room for 24 hours, and the only things they have in their room are they're given some paper and pencil and a can of food, but the can is closed and they're not given any can opener or any other obvious way to open the can. So 24 hours pass, and then the psychologist goes to check on them. First goes into the engineer's room. The engineer has not written anything on their paper. The wall of the room is full of dents. Turns out the engineer just threw the can over and over at the wall until the can split open. So next, the psychologist goes to the physicist's room, where their paper is full of equations and work. There's a single dent in the wall. This turns out the physicist calculated how to perfectly throw the can into the wall so it'll split open on the first throw. So finally, the psychologist goes into the mathematician's room. There's lots of equations and stuff scribbled on the paper. There are no dents in the wall. The can is still closed. The mathematician is nowhere to be seen. And there's some strange noises coming from the can. The psychologist quickly opens up the can, whereupon the mathematician jumps out of the can and says, "Oh, thanks for saving me. I guess I got a sign wrong somewhere."
Oh my God.
Watch your negative signs. It's the moral of the story. Or you too could end up trapped inside of your food. Instead of vice versa.
There's also an alternate version of that when they're on a desert island or something like that, and then the physicist and the engineer try similar approaches, and then the mathematician just sits down and says, "Assume we have a can opener."
Yeah. There's lots of variants on this type of joke. We've gotten to that section of my joke book, so we will be seeing some of those over the next one.
Do you have them memorized by the end of the day? Or do you just have...
By your class, I typically have them memorized, yes, because by your class, you're my third class of the day, so. First class, I usually have to use my joke book, so. All right, induction. So if you recall last time, induction was the process of proving something where you generally prove a statement for all natural numbers n by, first of all, proving it in the base case, which is usually 0 or 1, but not always. Then you assume that it holds true for some k, then prove that it has to hold true for k plus 1 under that assumption in order to have the domino effect of then proving it for all natural numbers. So what we would do is spend most of class today giving you all the opportunity to work on some problems. I have number one we did in class last time, but there's a 2, 3, and 4 that I'd like for you all to try working on in groups. Jacob, how am I splitting up groups today?
I'm in Alex's, and then it's free for all.
Jacob works by himself.
Okay.
Boom.
All right.
I'm okay with that situation.
There's one. All right. We have one. All right. There's one rule. I want groups of 3 or 4. 5, 6, 7, 8, 9, 10, 11, 12. 4 groups of 3. Adam, Alex, and Jacob all have to be in different groups. You all need to decide other than that.
Do we just go?
Go.
Oh.
Okay, Evan, do you want
You all can choose other than that.
I'm just gonna turn around.
Yeah, you can go first.
Griffin.
I think we got group.
Oh, sorry.
If you want a couple groups, if you want some groups of 4 going, that's fine too. I like it.
Alex, we have an open spot.
Oh, no.
No, not for him. You don't.
Okay. We gotta do the base case first, so try one.
I'm in there, but
Holly, you were kicked out of that group. You are now in that group. Alex, you were with Isabel and Sophie. I'm sorry, but it was for the greater good.
Well, we got Alex.
okay, I haven't done them yet, but they're pretty explanatory. Okay, so I showed the picture too.
I was gonna say is
I want his
is
brain.
that an upgrade from Holly to Alex or a
Well,
downgrade?
it's just like,
There is no correct answer to this question.
I came in
Only
to you
improved.
and made you feel wanted and you rejected me. Okay. So.
See, this is why I have to choose the groups myself, or we get drama.
I guess I'll just have to go. Exactly.
but
If you go up, this is stipulation.
Oh, it's time. Yeah, we're.
Oh, wait, yes, because you have to plug in K plus one for n, so
Yeah, so 1 equals 1. Now we do it for the n.
You have to prove the base case, so as long as you prove the base case
Yeah.
first, then you
Assume
can
n equals k.
then you can do the like K thing.
is this
Or is that?
Just random.
Man, you better put some good stuff to this. This part?
Yeah.
This one, we'll include all the elements to that.
We're gonna have to like factor somehow, and I'm not gonna do it anymore.
I think you got some good stuff there.
We good.
okay? Does it do like reformatted to fit in these?
Oh, I don't know. I haven't read it. You didn't tell me to read the other stuff.
Right. Wait.
I tell you what. Why don't you see what your group members think when you get to it?
What number?
But yeah, I think you have the right idea of what's going on there.
Are we all sure how to
Yeah.
And then we do the if n equals k plus 1.
Wait, you got like K squared.
I have one K squared. I left the K plus one factored out, but I guess that one. Wait, so like,
So you factored this K plus one, these like those two, and then you factored everything you multiplied this, the K times 2K. Sorry.
you're good.
I was distracted properly. That was almost so sick.
Oh, that would be tragic.
That would be.
Wait, so then
Unless you want a mistake so you have something to write about.
So mathematically, all we need to
So
do
what were you
is
getting at?
prove
That's the,
Third step.
for the K plus one, all we need to prove
proving the
is that
induction
this
step, so.
is just
So we,
this
do we just
with,
assume
yes,
that
K plus one squared.
Yeah, so we assume for some K.
Right, so we can prove that on both sides, we just added a K plus one squared.
Don't forget that it's.
So we just,
Yeah.
so we just assume,
With
so we don't have to prove it.
So we,
Just right to merge.
for the
That's where we'll
induction stuff, we
If
just
we
need
assume that.
Oh, yeah, yeah.
Then.
Got it.
yeah, using our induction
then-
hypothesis.
Eventually, it should look the same,
Eventually,
right? Also, proof it'll be the
Somehow.
same.
Somehow.
Whatever this equals.
I'm just doing math. And yes, so pretty much I want to get to there. Once I get to there. Because like once you get to here, you've already proved it. Because you proved that you just added a K plus one squared to both sides, which means it's an equivalent statement.
But you have to prove that this plus K plus one squared is equal to whatever this looks like. Breaking between those two.
This does the
I don't know how
same.
to get it to be in the same form.
It has to be in a form that is recognizable as
Yeah.
So
being what the
I don't
formula
think it's
tells
like
you
that.
you should get.
I think that
Right.
the
Yeah, it'd be a little convenient if you could just leave it however you wanted it. Call it good.
I mean, sure, then you have,
Okay, so you can just substitute.
and if you know what, if you wanna do that, then just, why bother?
You know what this.
Madness.
My life easier.
I'm not here to make your life easy.
So it's like this whole like sum up here.
You added it.
Yeah.
You added
Oh,
it.
yeah, okay.
Wait a minute.
Are you back?
Because
Are you different? Where is your induction hypothesis?
so here
We
is
just
my
induction hypothesis. Just expand that description, all of a sudden it just be the same thing.
Oh, dear.
And then at
What
the
expression do you not want to use?
I
chose
this.
I'll give you a hint.
Oh, I see.
I'll give you a hint. Go back to this step,
We should just like.
and then,
Somehow.
right, this is just plus
That
six
plus
cents
that.
over that.
How about that?
Then you combine the two without factoring, without like, factor out a
But
plus one.
I'm not quite sure what.
I do my best.
I was like, there has to be an easier one.
I mean, there is some amount of multiplying things out, but you can make it a little easier on yourself.
Do you
Well,
do you have a suggestion for
Yeah,
maybe
do
not
better.
just not in this case, but like generally when we're working on these? Like
How do we factor?
yeah, like I see that I think I get the idea of like the whole domino thing and these are supposed to be the same, but like actually showing it. Could we just
So actually showing it is very problem dependent, just a second, I'll get to you.
So I took this,
Um,
K plus 1 point.
Actually showing that your formula comes out to what you want it to can vary a lot from problem to problem. So like what you'll do for number 2 is probably completely different than how you'll do the induction step in number 3.
until
So
this,
I'll give you a hint for this one
until
though.
this line looks
Instead
like
of
this line.
multiplying all of this out,
Until.
factor out an x k plus 1 to the outside, and
Yes, that's what I'm working.
then the multiplying out won't be so bad.
okay.
I think I was asking that.
Yeah, ultimately you'd like to
I
get
was like,
something
so I was
like
like, all I,
a plus
yeah.
1 times k plus 2 times 2k plus 3.
doing.
You'd like to be able to factor the whole numerator.
Yeah.
I've
Yeah,
almost
that's
got it.
not- yeah.
So it's the
So-
plus.
Play around with some factoring and see what comes up.
So are you
Uh,
like right now I have
K
k times k plus 1 times
So
2k
from
plus
what we did
1
yesterday, we added a K
plus
on both sides,
the
'cause I did
6.
it wrong yesterday.
Oh, no.
k plus 1
Well, I
squared.
showed you, yeah.
So if we pull a k plus 1 out.
Oh yeah, that's right. Yeah, you the right steps, but kind of the wrong
Yeah.
formatting.
Together
So
get it out.
starting with adding K plus 1 squared to both sides and then
Yes, I multiplied the K plus 2
this to look like what it should look like.
So you
I have two K.
formula works for k squared. Yep, I'm on board so
Okay.
far.
Cool. I have
Thank you,
two
that's all.
K,
Yeah, I
just
think-
double checking.
I think you just now need to massage that so it looks like the form you want it to.
Yeah.
Now we want to have a.
So if you have your K
So it
plus
looks
1, then you
like-
make to make
That's just what you would like for these to be.
K plus 1, 2K squared.
Okay, so you're starting kind of from what you want it to be and working your way back.
I started with what I wanted to be and then I went back to.
Oh, you got it to here, and then you got from here to here, and so they kind of meet up in the middle.
Freshman,
Oh, does that not work?
It works, but I don't like it.
I'll say it because you.
So logically it works if you could show they're both equal to the same thing, then they have to equal to each other.
Okay.
But when you
For your
add-
final version, let's say, I want you to start with one end, so either the
Add the-
1 squared plus 2 squared up to the k plus 1 squared, or start with that and then work your way to the other, which is basically just taking your work and
Like the
rewriting
addition
it half as it goes
stuff.
backwards.
Yeah,
Yeah,
this
that's-
addition sign
that's-
is screwing everything.
But you have all the right steps, just.
How are you guys doing?
So I
Good
would
stuff.
have this.
So
Mm,
like
maybe.
six.
Are you
Yeah.
expanding?
I could write that out.
No,
I
so
tried
I
that.
am just.
Yeah, basically right now, I don't like that you have.
Okay, I think yeah, so let's
That looks like
multiply
there's
this
two
K out,
Wait, now you're
multiply the
just-
6 out and combine like, and I bet
So
it's
what I
gonna
want you to do is to
factor
say like,
plus two.
this is,
2K plus 3.
or I want you to start here, just to say that equals 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 that.
Yeah.
I know, that's the mistake.
And so
that I
basically
made.
you've been shown by a single string of
So now all we
equalities
have to
that
do
this
is
expression
show that
is equal to
this-
that expression.
Now this new
The fact
thing
that you kind of have this
looks
equal
like
sign right off the bat
it would
doesn't
look
sit
like
well in my
if
gut.
this were true.
Makes it look like you're
Okay,
doing the
so-
forbidden thing of assuming the result you're trying to show.
Patrick Ursel, did I
Well,
find
you'd have to combine that and then find a way to
Uh,
do it so it's supposed. So this is what it's supposed to be.
Wait, so
so
you're
yeah.
able to factor in the 2K plus 1 out of the
I like the-
2K
Let's
squared
go
plus
out
7K
here,
minus
and then you
this,
factored out a
see if this.
So now we've got to
I'm
manipulate
really
this
confused.
and show that it's the same as
And then,
this.
Yeah, I don't, cause yeah, you're going the opposite way.
So I feel to get that.
So,
Oh,
you
yeah,
I
factored
did this.
wrong here.
Yeah, so like if
This
we added
2K times
a
K plus 1 would give you a 2K squared plus 2K. out of
Oh, I
2K
wanted
squared.
to, where are you getting?
This thing,
But I
I'm
think,
gonna factor out to be those two terms.
I think I agree with everything up to this.
Oh, that's the part of the denominator.
Yeah, you're just,
That
you're.
makes sense.
Say what?
I love this.
Good, so fun.
Oh, you're gonna love it when we get to complete induction then next week.
Used up all my room.
This is
That factors into those because it'll
No,
be
that's literally the first.
2K squared, 3K, 4K, 7K.
Cause I just wanna get out,
So in the end, you'll have.
so at the end of the day, I need to get out 2K plus 1, a K
K
plus
plus
1,
1 times K plus 2
and
times
a K
2K
squared
plus
Induction step.
no, K plus 1 squared. So what I want is K cubed.
I don't know how to,
Yeah, I guess I didn't actually factor this. I just checked to see if these two terms, when you FOIL them out, it came out to that.
So,
Quick question,
Yes,
I don't think you need.
how do we end the
Yeah.
process? Like once we prove that it's the same, how
I
do
would
we-
say then, like the very end of the proof, say something like, thus by induction,
Well,
we
you
know
want to-
that,
You
and
want
then
this as your final result.
formula
No, I
you,
think we want this.
formula you've proven is true.
Will that equal to
Or thus we've proven that by induction, we
this.
know
And then
that
you can
whatever the
subtract
industry statement
that from both
says.
sides?
Thank
And that proves the original. So this is our goal.
I don't know what to do.
Over.
See what your group members have to say.
Okay,
So then-
so
Think would be good.
I think maybe the, so,
Y'all doing all right back
can
here?
I score?
This.
I think you got, think you got the
For
first
all
one.
of them.
Yeah, it took 20 million years.
I'll just wait till you get to the third one.
I don't like the way y'all are doing this. Not a fan.
Eh,
That's
I know, but I did, that's pretty.
So here's the deal. Here's
I'll
what
say
I
this on
would
this
do.
packet.
Is I would
With
start
possible
with this
exception
factor.
of the
So I want K, then a K
That,
plus
that one
1.
is
Wait, what do you mean?
the
Like,
most
so-
algebraically messy.
Yeah,
The next couple are less algebraically messy or
it's actually messy.
Just actually.
trying to figure out what to do messy.
Yeah. What did you say, so by induction for all?
Yeah, no, I think you should start with
I think, I
having
just said, like,
this
thus by
equal
induction,
to
to be proven.
K plus 1,
Well, you're
this
just.
equal to K plus 2, and this equal to, what is that, 3K. So you should plug in at each of the Ks a K plus 1, and then work down to this result, that you just have one of those added on both sides.
Wait, oh, it's still gonna start your
Yes.
No, that's exactly what you just told me now.
Well, on the example, he just added like, or here, he just
Okay.
added K plus
Questions
one.
for me?
Yes, so I assume that by this,
Okay,
I'm just plugging in all the Ks,
next one we got.
K plus 1 squared,
So,
right,
This is
or
what I
K
was
plus
just
1.
wondering.
See, basically you're
And
just
so I'm
taking your,
plugging in everywhere, and then I'm
But I'm trying to
work
look
down
like this,
to
right?
proving that
I already
this
have my
is equal to,
Right, so now you just.
whatever, this
Wait,
plus
you
K
did
so
plus
this is what you're trying to prove right here.
plus one.
that
into
that expression comes out to this
Okay.
expression.
Okay.
You don't want to start by setting those equal because.
Okay.
And you.
So what I think you could do here, Griffin, is
Yeah.
So like this is already, this is n.
Boom. It
Yeah,
works.
this is like.
if you're using your induction hypothesis,
So now you just have.
Oh, wait,
Then-
it's starting to zoom.
what you can use is say, well, these come out to the k times k plus 1 times 2k plus 1
No,
over
you
6.
distributed, and now you combine this and you'll get a quadratic.
So.
So I think this is kind of going to be your first line in the inductive step.
Yeah.
And then your goal is going to be to do a bunch of algebra to show that that then comes out to k plus 1 times
Now we have the
k plus 1 plus 1
tricky step.
times 2k plus 1 plus 1
Yeah.
all over 6. And I think your goal is going to be to kind of
Yeah, I
get the algebra to make this, do the steps that eventually show that
You
equals.
might be done then.
What? No, I'm not.
You're,
Did I stack here wrong again?
well, you're not that far.
I don't, but
I like how you
But I
started
have
out,
like a
Lori. I think you're
6.
close.
I have a 6 and I don't have a 2.
Can I see what you
So
have?
you're showing
I
that.
think we're gonna have to use natural log. for
Like
this.
I got to the
Did you get like the?
So here it might actually be
whole
helpful to just
sequence thing is
multiply,
that it's a
not the k
2K,
plus 1 here, but the rest of this out,
Plus 2 to the k.
and then see if that
Well,
factors
I-
into, say,
Either
something.
the k plus 1 plus 1 or 2 to the k
So I
plus 2
should, in this step, I should just like factored this
Yeah.
whole thing.
minus
up
1.
to here.
Yeah, multiply that out, leave
I'm
the
in
k
the
plus 1,
multiplier.
leave the k plus 1 out front, but
So then
multiply
we
the
have
rest of it out.
Sub
Once you've multiplied it out, see if you can find a way to factor that.
So,
K plus 1 plus
2.
So this one you put in and it was, oh, sorry. Which step are you on?
The third.
Yeah.
You just add.
So we say if
From here, right?
Okay.
Can I show you a
this
fun
one.
fact here?
Oh, we write if.
Oh my gosh, I love this.
So we have
I
assumed that it's
had
n
a
equals
fact
k,
when I was
and
taught
we're just
this in
assuming
high
that
school, I
that's what
would
it is.
with the 2K.
So,
And then the induction step is we're saying, well, 1 past that one.
because I find this to be a lot easier, especially
Yeah.
when you've got some time in front of the k squared, because I like usually.
K plus 1 plus 1.
Yeah, usually it's 1.
I'm getting there.
In front of the. Okay, 2.
So this is,
factor,
right, this is
factor.
2.
So basically.
Since you have.
So then we can, for that, the first k terms, we know that that's equal to 2 to the k plus 1 minus 1.
In front of your x squared,
And then plus the,
Well,
and what's in front of your
Yes.
K plus
2
1, or
plus
what
6.
your constant is.
Yeah.
Wait,
So
no,
you
factor
can-
no,
So
it's
it's 2 times, right, so it's.
I don't know. Wait, it has to be 6 and 1, right?
2 times.
But would that not be, would that
So, okay.
2 times.
The first step, yeah, is to think about all the different ways that.
No, wait, it can't be that.
That helps.
Yeah.
No, I have to be 3 and 2.
I don't look at yours.
I have
Bonus.
squares in here.
Oh, it's, yeah, I got
Oh,
you.
no, we want, you got 1 and 6, we want 2 and 3.
That's in case you really want to have, you really enjoy doing this algebra and playing around with, you can,
Okay, is it 2k plus 3 times k plus 2?
Because if you find, so it's k plus 1 equals
You did it.
Oh,
So,
I did it! I
for
did it!
the if k
Oh, wait, no.
equals 1, and then you'd write out like.
you got it to work out, Laurie?
0 plus 2.
All right.
Plus
I guess
2 dot 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 dot.
Why are
Plus 2
we
to
so
k
bad at
plus 2 to
Literally
k
every
plus
week in
1.
calculus in high school,
Equals
teachers
2
being
to
like,
I feel like
K
you
plus
just
2
exactly
minus 1.
proved it.
And then for the first k terms, we
No,
said
it's
instead of 2,
I don't remember
that that was
No,
2
so
to the k
then
plus
that's
1
a-
minus 1.
This has probably been the most algebraically intensive problem I've given you to work on in this class.
We said the step.
As opposed to
before,
conceptually
that was
difficult, this one's more
2 to the k plus 1 minus 1.
just messy with the algebra.
So now that, yeah, we're gonna sub that in, and then it's plus 2 to the k plus 1. And now we have to figure out how to make that look like 2 to the k plus 2 minus 1.
It is definitely kind of weird.
It's a weird way.
Yeah.
So
Um,
we're evaluating. K
so this next step, do I follow you? Okay, I follow you.
Once you write-
Okay, but then you write this out.
All the like algorithms so easy, and then like once you
How did you get?
So like, I feel like
everything goes out the window.
when I
2 to the k plus
did
1
this
plus
very
When you
little
said
bit
the
in high
factor,
school, it was like, my big thing was,
plus x.
Which
I
I did
always
not
wanted to-
realize.
Okay.
it's like you just have to assume this is true,
That makes sense.
and it's like you just take it for granted.
That's the sneaky part.
Yeah,
Like
that
you-
is like
like, when I was doing it, I always get stuck up on like,
It's,
how do I know
it seems
that?
obvious when you think
It's
like
like
x
you don't
plus
have
x
to.
equals 2x, but
You just
if you
have to
replace
keep
x
going
with
and use it.
2 to the k plus 1 or whatever, then it gets a little bit
So once
weird
you've
to think
written this,
about.
we can just say by induction, this is true.
Oh, you factored out a k plus 1.
Okay.
You got it. One time.
I multiplied them all.
No, well, number 3. It just add, the 2 to the k plus 1 plus 2 to the k plus 1 is 2 times 2 to the k plus 1. Which is 2 to the first times 2 to the k plus 1, you just add.
Oh, goes. 2 to the k plus 1 plus 2 to the k plus 1 is
2 times 2 to the k plus 1.
Oh, yeah, I see what you're saying.
The proof by contrapositive, or one of the, you have to do that for one of the proof by contrapositives for the proof portfolio. That's how many.
What, thing plus thing equals 2 times thing?
And then
It's like
these
proving that
two
6 to the
two times that is really 2 to the
Oh, yeah, that
one.
one. I remember that,
And
yeah.
have to factor recognize that.
So really 2 is 2 to the 1.
So is the base case 0 or like, there's no like, there's no like definite, yeah.
Because
Yeah, I don't.
So-
agree with X.
So in general, you just have to think about what's the smallest value of n for which this makes sense.
You just kind of.
Technically, if I say natural, I guess in this one you could do 0 elements and it works out. That was someone's presentation last time. So you could do 0 and have that be your base case. If you want to, you could have 1 be your base case and then
And it's,
0 is inside.
we don't change the base of that when we multiply. It's a 4.
The power set is this way.
Because since we're
Yeah,
adding the X's together, the base, we can do that because they're the same base.
I think I got there.
Oh, yeah. That has 0.
That has-
So the power set is just one element.
I'm gonna look at my bad factoring, but my factoring that's correct. I stopped writing that over 6 because I just had to get out. I had to save space because I write math very large.
Did you argue this one as well?
Do you see where you went wrong?
When?
Did you do this? Oh, I thought you said you did it
This
wrong.
morning.
Oh, did
I thought it was a proof portfolio, bro.
Oh my
I
goodness.
did like my approach of meeting in the middle.
I told you, I wanted Alex in my group. It's got all the answers.
See, this is why I have to take action to split up the group somehow.
Is there? Why would you think you'd roll for how you portfolio at the top?
Crazy how that works.
That's the bad.
So with,
So we
for
have so
instance, you
much.
have something like
Anyway.
2 to the k plus 1 plus 2 to the k plus 1. Alright.
Except.
Say that again, Lauren?
Isn't it 2 to the 2 times k plus 1?
Like that?
So it's 2k.
Oh.
No,
Hold on, let's do what it says, Elmer. We're gonna ask until you can add these, what would you get?
If S is the set.
If I were to give you
Ever since you're studying
we
for
just got
GRE,
started.
it just drives me
that, what would you get?
If X has one element.
If I were to give,
So is.
if I were to give you 2 to the k plus 1 plus 2 to the k plus 1,
I'm here and I'm trying to get it equal.
Okay, here you go.
But how do I get the 2 from there to the k plus 2?
No, it's fine, just right on the.
Two.
Wow. Okay, thank you.
if that helps. That's, sorry, I wasn't sure what exactly your question was, but.
Yeah, no, that was weird.
Plus 1.
And the element too.
Plus 1, which is 3.
How, wait. Oh.
Because if 2 to the k plus 1 plus 2 to the k plus 1 is 2 to the 2 times k plus 1.
Wait, okay. So we have.
Okay, so for the second one, do you want it to be, is that what you're trying to get to?
No, because you're not
two to the-
squaring. Well, I'm like,
No, no, you're not squaring.
because you're adding it twice.
It's like a way you're
adding
showing that.
one
Yeah,
and
so-
two.
Which has two elements.
Same hint I gave over there.
No, because this is, I know, I
So like, I know you could like, oh,
Yeah.
Yeah.
like I guess you could split it into 2 times 2 is 2k.
Yeah, because this exponent is a one, so
Okay.
you just add a one. Yeah, no, I had to process.
No, I'm not saying right on cursor. I thought he said that was wrong.
Yeah, I think that's.
Oh, don't feel bad if it takes you minutes, if you take you some time to process.
Okay, elements.
My gosh.
So smart.
Dr. Gerst, you had me doubting myself in exponent. I was like, there's no way this is
Do you
wrong.
guys remember, like, I.
Well, I wasn't saying no to, like,
And I feel like
I
I was
wasn't
bad
paying
at
any
it.
attention to you. I was just remarking on something
I
Paul had
couldn't
written
tell, I
down.
thought, well, I had written what I,
Yeah.
like, I was showing her what I did, and I
Like,
think,
it wasn't
well, I just wrong, like,
hard, but like,
I was like,
really,
there's no way
we
that's
did
wrong.
it, and I just-
Yeah, sure.
Okay, we're good.
You're good.
Okay. Yeah, Holly, you're good.
Mhm.
No.
Oh.
Hearing a lot of O's.
We'd like call it a set.
This, adding a power of 2 to a power of 2 gives you 2 times that power of 2.
So,
Wait,
So then there's
The magic of x plus x equals 2x.
So this is just a really short proof.
I don't think it matters.
I don't think so.
so
I mean, for the, yeah.
Then you need a line to conclude it, yeah.
Okay, so I'm still manipulating.
But yeah, I will say this, my
Subsets.
proof for number 3 was definitely shorter than my proof for number 2.
So if you add.
So we're at this point where we have 2 times 2k times 2. Because 2k plus 1 is 2k times 2.
So instead of k plus 1,
And so I combine them.
or is it like?
I don't know how to show this.
K plus 1 case.
I don't really know where I'm going. Like, I mean, obviously I know that I'm going to,
Okay.
what is that? 2k
Set.
plus 2 minus 1 is the goal.
So like what is, so like the set with n elements?
So we use,
is the
sorry,
set?
k becomes k plus 1. So yeah, 2k plus.
I don't know
the
how to
goal
write
is
this,
2k
but
plus,
like the only difference between these two sets is one is
Oh yeah.
this
and
set
so I'm
or
actually, I
has,
think I'm almost there because because I could just do 2k.
and then this other new s,
It's the same thing, just plus 1.
Yeah,
yeah,
yeah, this
it's
one's a
like
bit tricky to
everything
write
is the
out.
same.
Yeah, I guess because I just don't like,
Da, da, da,
I guess
da.
how would you
Okay,
like
equals
express
1.
Show
the
us
number of
what
elements that's only in
2k plus
p of k plus 1.
So you
So we know-
that the set.
Okay, yeah,
plus
that's
1
like getting
elements,
kind
this
creative.
power set is gonna be
Yeah.
all subsets that are in.
It is getting creative.
this thing. And then
I really got them.
there's also going to be there's gonna be a set of subsets which
And then you have the 2 on the outside, and then that gets clear.
is included in all those
Okay,
subsets.
yeah, no, I agree with that.
Yes, okay.
Does that help?
It's almost like team of that.
Which counts.
S has K,
Can't read it.
S, what's T?
Subset with k elements.
Yes, it's,
This is a response to a question from another group. This is have you seen this for number 4?
Are you guys in number 4?
I feel like
Do you
intuitively,
think you're doing
this makes
base
sense.
case for any?
just like if you're thinking about like in theory probability, we've been doing so many like
Yeah, I like that.
combinations problems that it's like
I'm kind of
each one you now
thinking about
have
writing something.
one more, so
Like,
it's
are
like
you
we're doing
just
another
right, like,
kind.
do that for
But I can't like write this out.
Yeah, yeah, well,
Doing that for some.
you're in probability now. When we get to combinatorics week in a couple weeks, you're gonna be well prepared.
Let's
Oh
go.
wait, do you have to
I
do
hate
you have to
Calc.
make up a new
I'm so bad at it
T
though. It's so hard for
Do
me.
you have to make up a new
They're
S?
like,
Like a new set?
you could also prove this
That's not S.
combinatorially, right?
For this
Because
case?
it's just like, you choose,
Oh, a
you can
set
either
that
choose
is
to
the order of
include
it?
an element,
Well, you know, if you have to pick like
the,
A
you can either,
instead of
in the
N.
power, in
So
composing
do
the
you have
power
to
set, you can
like
either choose to include an element,
T,
or you
So we have
don't
to show
have
that.
to.
where you could like K
So-
elements?
And each one's gonna
Yeah.
give you the same amount of
I
opportunity.
did like
Yeah,
ask
so it's like
some
two.
the number of elements.
That's in essence what the inductive proof is that I'm going for here. But yeah, you could rephrase it in a much more combinatorial way if you were to so choose.
For some set
Only that would help me more.
T elements.
The last part's throwing me off.
I just
You have
don't
for some-
understand anything.
So,
Some
like,
set.
okay, what,
It's been really sensitive because I really like that I just add them all.
This one is not algebraically messy, but it's more conceptually messy.
So
or power set that-
let's try using that. If we take our second step, instead of instead of S is a set with
X,
N equals K,
and R
we'll say T,
an element of power set of S.
and then we can
Is
try
this
and use that.
the assumption
So
that
combination
things
So-
look like?
S is a set with N equals K plus 1.
R is
The power set
just
of that is that.
one of the
Yes.
elements.
So what?
So now
Oh, because then there will be two.
I said
our
assume
next
that-
line is, because then it'll be
Yeah.
T
there'll
is
be two
really our-
subsets, which is
2 to the K, right?
two to the right.
Or the power set of T. So I think we can at least get somewhere with that.
So then,
I just rewrote Lisa.
I just did S sub K.
And we've just proved it.
Oh,
Yeah, and we had, if we did this one, we
Okay.
know that
Then-
the union of the power sets is the same as the power set of union. So,
okay, X is
Wait,
included,
okay.
X is in T, but X is not in S.
Or
Yeah, no, S is not in S.
How do you add one?
So,
How do you add one to like the set?
Why is it only some X that is an element?
Oh, for some reason I was thinking that as like X is in S and
Oh,
X is
X
in
is
T,
the
but that's
K.
I
not.
really like that power set problem.
Yeah, the X represents the plus one.
So that X is just that extra one.
Yeah, it's that.
Oh, that kind of.
That's of one.
Not completely.
Okay,
And then.
so if T has K plus one elements,
You say, how do you
S.
write that?
And then we
Like,
already
how
said
do you-
S.
So then,
Okay.
like, how do you write the set T with an extra element?
okay,
Or should I just write like some set S and then say that T is a,
and just say has K plus one elements. Does that make sense?
so are these two different sets?
Well, no, it's that we're proving that a set S with n elements has k to the n elements.
Okay, so now
But
it's
we
like-
have to show that the power set does. And so we're saying choose
Union
some
of the power,
element
wait,
k.
the power set of the union of these, right? Would then be equal to
Two.
element K, not some number of elements K?
Yeah, I guess. Some number of elements, k.
Wait, so for the assumption, would you write the set S, but then in the induction step, would you say some element T that is S plus another
Oh.
element?
right, because so if that first one has, this is the same thing,
Is it
of that
two
exponent
times?
rule. If we can prove that
You
2
all
times
know.
the power set of T
I don't know, I'm confused.
is,
And then think about this.
because the power set of T has K elements, or this 2
My
K
brain is still
elements,
like gonna.
which is what we want,
I'm so confused how to write like
because P of S has 2 to the K plus 1.
Yeah,
the, how are you supposed to show that it has like an extra?
I know this is something you have trouble with, right? So I'm gonna rewrite this in a way that might be more helpful.
2 times 2 to the K.
Ow, thanks. Really helpful.
Glad I can help.
Wait, I don't get
why is that, like, why is this approved?
So it has one more element.
Because it's 2 to the, and so 2 to the.
And so the order,
Why does adding one element multiply the number of possible subsets by 2?
because
Wait, I'm confused, what is?
you added one more element.
T is just some set with k elements.
That's our
Hypothesis, right?
Well, your induction hypothesis should be something like assume that any set with k elements has to have a power set with 2 to the k elements. And then your goal, and then your induction step is to then say, assume we have a set with k plus 1 elements, and then your goal from that is to then prove that that power set has 2 to the k plus 1 elements. You know, your favorite,
But,
2 to the k.
so in the assumption step, are we not supposed to say?
I have no idea what I'm doing.
So this is not like necessarily like part of the proof, this is
Yeah,
me,
that's what I was kinda,
this is me just saying
I
like,
just
how
called
can you
it
talk
W.
about like if you have some set with k plus 1 elements, how
I
can
don't know, but
you break it
even
down into a
then,
set with s elements and something else?
now if you start like
It's an
subbing
extra
in that
notation
as
here.
having so many
So I think your
elements.
induction hypothesis is just assume all k element sets have 2 to the k
But
elements in their power.
I don't know how to write these out because it's
that.
like
And
counting
then
the
your
number
induction,
of
and then your, and then you can say let S be a set with 2 to the k plus, or not 2 to the k, k plus 1 elements.
you're just using words.
And then your goal is to end up by
Power set of T
proving
with the union of power
that
set of T be
the power set of your new
What's
S,
the set
the power set of your k plus 1 element set has to have 2 to the k plus 1 elements.
Sorry.
That's X, right?
So with the power set of T,
Why
the
is it so hard to
union
understand?
of power set
Because
of T.
these are really tricky to write.
That equal to.
So here, let's write this down, so I'm not just saying things.
2.
So I think your induction hypothesis
2 to the K plus.
Well,
Not 2 to the K plus.
is,
Maybe, but I don't know what that says about the number of
assume-
elements still.
Well, that would
Any
only. mean
set
that
S
with
with
power set of T.
k elements
That's like.
And then that has 2 to the K subsets.
satisfies
Power set of
But then I don't know what.
that the power set of S
Here to-
Two times power set of T equals power set of.
as 2 to the k.
Just say that like X.
Okay.
So that's, so I think that's gonna be your induction.
Maybe write out what you're saying.
Like,
I can't write
Oh,
that.
sorry, this just means,
Because like.
So.
this is just a shorthand notation for the number of elements in a
Oh my
set.
gosh, that makes so much more sense now.
Communities is not equal.
Oh, okay, that's what you
I
were
really
saying.
struggle with that.
Notation and multiplying by 2. I found your weaknesses. I'm sorry, I should stop teasing yourself. I don't know that x plus x equals 2x.
How did I rectify this? It may not be possible.
Are the
I
doors
may
still?
be stuck
This will
here.
take extensive work that will last the rest of the semester and beyond. Yes.
We just get
Yeah,
like
Yeah,
a
because
nudge.
you can literally just say that this
We're-
is 2 to the
Wait,
K.
okay.
So let me see what you get.
And then
So
you
you
can
have,
say
you're
that's
assuming
a
that
power set of
if
that.
you have a set with k elements, the power set's 2 to the k elements. And then this is what you
But I
want.
also feel like.
Yeah.
So if you take a 2 to the k, so if you take a k plus 1 element set, you could sort of think about it as being a k element set, and then you have another element.
Yep.
So think about it this way. Let's, what are you calling your bigger set, the one with k plus 1
You're
elements?
saying.
So, okay, so S has k plus 1 elements. So let A be an element of the, everybody's getting quiet to listen in. Let A be an element in the power set of S.
You're saying
Yeah.
no. How's that not?
A, so A has to be, so that means A is a subset of S, right?
Saying you know, you can split them up
Yeah.
into two distinct.
By definition.
Yeah, I had to think through it, it's alright.
The subset and ones which don't. You already
I
know
think you're gonna have to look at two different cases. One where A
X is 2
is a subset of T,
and
and one where A is not a subset of T. And you could sort of think about, in each case, how many different possible sets could A be?
So that's just saying whether or not A is like unique to S, like in case 1, it's not.
So case 1, your A is a subset of T, and so you could think
So it's
about,
already in T, like,
so how many sets could A possibly be
Yeah,
equal
the
to?
order
How many possibilities for
number
A
of
does this give you if A is a subset of your set with K elements in it?
2 to the
by
K.
your induction hypothesis.
Right.
So this leads to
I know this because I
2
figured
to
this
the
out
K
very
possible
quickly, so I just
sets.
saw the pattern and I was like, oh, but actually say it, so I think what you're doing,
So then you have to consider this case
the number of
where A
elements
is not a
is 2 to the
subset of
n.
T.
Obviously, we can't assume that.
How many
But the
possible
reason
sets
that's
could
2 to the n
A be
is
if A?
because
So
sometimes like the way they're combined.
if A
By
is not a
adding
subset of
one
T,
more
but A
element,
is a subset of S,
it's
what does
the
that tell you
same
has to be an element of A?
as doing
It has to be an element of A.
2
2 to the K plus.
Wait, sorry.
2 to the
not
K.
exactly that.
Well, I'm not looking for a
That's
number
how
here.
many.
The
Basi-
one
But
element
it
is
is,
not.
I mean, it is
Yeah.
that,
Yeah,
but
if you use what I wrote on the board there, that
I
X
don't
has to
have
be an
explained
A.
why.
So,
So then A is gonna be equal to
Which I
X,
know, I
It's gonna be
understand this is
equal to this
equivalent to the end.
union,
okay, so if we have S equals 1, and
I'll let you write this more formally, but
we want to add a second offset S 1, comma 2, then.
and so you might think about how many possibilities for A are there in this case
We would
as well.
have 1 as an offset,
No.
but then we'll also have 1 plus
2
2
to
and
the-
1 plus 2. So we just add a
1.
new element to every element that's,
I'll let you think
every
about
set
that.
that's already.
Right. A has, for X, there's,
So
we
you
just
have
said
what you
that,
already
that was
have,
the first thing.
and then you have
There's 2 to
that new
1,
element
and
with
the
added
subset of
into
T has,
Yes.
But I don't know how to like
Okay.
actually
Is
that
this
for
what
you.
you, is
Yeah, they're gonna find
this
that.
what you
Case
said?
two.
I should take a picture of
This
that.
this one's definitely a tough
I'm not
one.
sure how to write it.
Dr. Gerst,
Yes.
we
Yes.
figured this out in words, but not notation.
So we can't say.
So
Okay.
pretty much the
What do you-
reason
what
that
do
when
you-
you add a new one, you maintain everything you had previously, in that power set. Because those are just all of them sans the K plus 1.
So that gives you 2 to the K.
Yes, and then you also, but then you have twice as many because you have all of those also with the K setup, with that K plus 1.
So the same sets as before, but just with that extra X tagged on.
Yes,
Ooh, so that'll give you an extra 2 to the K to work with.
yes.
I don't know.
I like it.
Okay, Alex.
I'm so lost.
So I'll give you a hint. I kind of started you off over on the board there.
Because the set is already.
Basically, case 1 is so basically any element in the power set of S is either going to be already in the power set of your T, in which case there's 2 to the K possibilities, or if it's not a subset of T, in which case it's going to be one of those subset of T union, that extra element, like you said.
Not signing up for that one.
But I think try working with this for a little bit and see what that gives.
Wait, he was
But you're
saying-
definitely, I definitely agree with your overall argument of what you're going to get there.
Will you just explain that again?
Yeah.
I don't even know all the different
I proved that
So,
2 times.
when you add
Power
power,
set of
You all doing
you
okay?
have everything that you already had, right? Plus the new elements,
Well,
which are everything you
That's
had
true.
with that new
if you,
element.
the power set of T, we said has 2 to the K elements. And if the power set of S,
So you want me to
we're
show you?
saying has
Or-
With the A is a
2 to the K
subset
plus
of
1,
T.
and that's just that same exponent.
So all the subsets that included.
That is true.
I'm following, I think you're really close to like understanding where to go.
There's just like one small step.
But how did that tell you that you're?
So, does it make sense? If A is a subset of T, then there's 2 to the K possible things A
So
could
we
be,
have,
because if T is a set with S,
Yes, that's what I was understanding.
so if T is a set with K elements, then by your induction hypothesis.
one,
Right.
X
and
is
zero.
X is an element of
So now we
this
have the
set.
power
Correct.
set,
So X is the element of this set.
and so we still have
So what's
everything
the
we had
last
before,
two?
we have the one set, we have the empty set, we have the empty set plus 2.
And we went
Which
through,
is
for the
2.
collegiate day, I didn't even notice during the
So
game, that's how
it's
much I can pay attention to who's throwing the ball. I didn't even notice we had
So it's-
rotated through.
Oops, sorry.
You're good.
That was like.
Okay, I just want to make a quick announcement. We are about out of time for today. We'll do presentations of these 3 proofs on Monday, and then before we move on to kind of a special form of induction, let's just say. These are definitely hard proofs. The first one was kind of algebraically messy. This power set one that I think most of the groups are thinking about is definitely conceptually a tricky one to wrap your mind around. Don't feel bad if you're not getting it right away. These types of proofs, I think, definitely take some time getting used to. So when we come back on Monday, we'll continue our discussion of induction. But in the meantime, have a good weekend, everybody.
Thank you.